To show that these two equations are compatible and we need to find their solution. So we need to first consider what is f and what is g, and then we need to find fg, that is in the bracket. You may call this as a Poisson bracket, and this should be 0. If this is equal to 0, that means these equations are compatible, right? And also we need to check the Jacobian to be non-zero and then find the solution. So let's consider f to be equal to xp minus yq minus x, and taking the g to be likewise x square p plus q minus xz. So considering these two functions, then we need to check this bracket. This should be non-zero, and what is this to be equivalent to? It is the partial derivative of fg with respect to xp plus p times the partial derivative of fg with respect to zp. When we have p over here, we should have z with p. The partial derivative of fg with respect to zq. Please remember this. And let's find out this. Okay, finding the Jacobian of fj with respect to xp, that gives you the partial derivative of f with respect to x into the partial derivative of g with respect to p. The partial derivative of f with respect to x, the partial derivative of g with respect to p, then minus the partial derivative of f with respect to p into the partial derivative of g with respect to x, plus similarly writing this also, partial derivative of f with respect to z, fz, into gp minus then fp into gz. Right? Then writing the third term, it is fy into gq minus fq and then the fourth term, q into fz gq minus fqgz. So now finding the values for this, fx, that is the derivative of f with respect to x. So from here we get p minus 1. gp, that is derivating g with respect to p. So from here we get x square minus derivating f with respect to p, we get x into derivating g with respect to x. So that will be 2xp minus z. So this is for the first term in the bracket, plus p times, okay, derivating f with respect to z. There is no z over here, so this is 0, no need to find gp then, minus derivating f with respect to p, that is x, derivating g with respect to z, we get minus x. So I'm writing here this to be x square. It's px square, right? Okay. Plus derivating f with respect to y, we get minus q into derivating g with respect to q, we get 1 minus derivating f with respect to q, we have minus y. Derivating g with respect to y, there is no y over here, so this is 0. So we are having only minus q plus q times derivating f with respect to z, there is no z over here, so we have, this is 0. There is no need to find gq because it is already multiplied with 0. Minus fq, derivating f with respect to q, we have minus y, and derivating g with respect to z, we have minus x. So that means we have this to be minus xy or minus xyq. So this is minus xyq, right? Okay, opening these brackets, for the first term we have px square minus x square, and then minus 2x square p plus xz. And then we have plus px square minus cube minus xy cube. Very fine, alright. So this is minus 2x square p and we have px square and px square. So this is totally cancelling out. And we have here xz minus x square minus q minus xy cube. Let me take x common from first and the last term. So this is x into z minus y cube. These two equations. From here I can get the value of xz to be x square p plus q. I'm using this value. So I'm writing in place of xz to be x square p plus q. Then this is minus x square minus q minus xy q, right? This q is cancelled out with this. And now taking x common from the first and the last term. So this is x into xp minus yq, right? Minus x square. So this is equal to x. What is this? xp minus yq is, from the first equation, xp minus yq is x, right? So writing here x minus x square, and this is x square minus x square, so that is equal to 0. Yes, we are getting the Poisson bracket of fg to be equal to 0. That means the equations are compatible, right? So hence the given equations are compatible. Now we need to just find the solution, and also we need to check the Jacobian of fg with respect to pq. So we are observing that the Jacobian, that is the partial derivative of fg with respect to pq, that should be equal to what? So this is fp into gq minus fq into gp. I remember like this, fp into gq minus, then cross multiply fq into gp. Here fp means partial derivative of f with respect to p, right? gq is partial derivative of g with respect to q. So let's solve this. We have, what is fp from here? From here only, partial derivative of f with respect to p, we are getting fp to be, yes, it is x, right? And we are getting gq to be equal to derivating g with respect to q. We have, this is 1, and then fq is, it is minus y, and gp is equal to x square, right? So let's put all these values. fp into gq is x minus fq into gp. fq into gp is minus x square y. That is minus x square y, right? So if we find here, this is x plus x square y, that is equal to, if I take x common, I get 1 plus xy. Now this 1 plus xy is non-zero in the domain. In the domain D, 1 plus xy is non-zero. What is the domain D where f equal to 0 and these equations are solvable for p and q, right? And also where dz equal to p dx plus q dy, this is valid. So domain is a region where this is valid, and also for these two equations p and q are solvable. So next step, we need to find now the value of p and the value of q from the equations f equal to 0 and g equal to 0. Let me name this as equation 1 and this to be as 2 to get the value of p and q. What I need to do is, let me multiply the second equation with y, so that I can get yq in the second term, and on adding these two will be cancelled out, and then from here we can find the value of p. So let's add these two equations first. and we get p into x plus x square y minus x into 1 plus zy equals to 0. I can take x common from this. So this is px into 1 plus xy minus x into 1 plus zy equals to 0. Dividing both the sides with x, we get p into 1 plus xy equals to 1 plus zy, which can be written as, we can find the value of p to be 1 plus zy divided by 1 plus xy. So this is the value for p, and now we are going to get the value for q. Just put the value of p in any of these two equations and get the value of q. Let me put the value of p in this first equation, so that I can get the value of q to be x into z minus x divided by, please solve this on your own, 1 plus xy. So we have got the value of q also. Now the equation dz equal to p dx plus q dy becomes, just put the value of p over here, 1 plus yz divided by 1 plus xy dx plus the value of q, x into z minus x divided by 1 plus xy dy, and here we have dz. Because I'm having z minus x over here, so let me add and subtract x from z, divided by 1 plus xy, and the second term, taking these two together. So we have 1 plus y into z minus x plus xy divided by 1 plus xy dx plus x into z minus x divided by 1 plus xy dy. Let's multiply this dx inside. So here we have 1 plus y into z minus x divided by 1 plus xy dx plus the second term. Multiplying dx inside, we have dx plus y into z minus x divided by 1 plus xy dx plus the third term. Here we have dz. Here I'm having z minus x, here also I'm having z minus x. Let me take this dx to the other side. We have dz minus dx, and when taking this z minus x common, I'm taking this to the denominator of this, and here we have y dx plus x dy divided by 1 plus xy. I hope this step is clear. Yes? Okay. So which can be further written as, it is z minus x, it is the derivative of z minus x divided by z minus x equals to the derivative of, okay, first function the derivative of second plus second function the derivative of first. So the numerator can be written as derivative of the product of xy. So derivative of the product xy divided by 1 plus xy. Integrating both the sides, we get here z minus x, and here we can write the derivative of xy to be derivative of 1 plus xy. Can I write like this? Yes? Please look at over here. What is derivative of 1 plus xy? It is the derivative of 1, which is 0, plus the derivative of the product. So I can write this dxy to be equal to d of 1 plus xy. 1 plus xy and the constant, and here z minus x. So we have the solution z equal to x plus 1 plus xy plus the constant to be the required solution, which is the one parameter family of common solutions of the compatible equations f equal to 0 and g equal to 0, right? Okay, thank you. Stay blessed.